Today we're going to talk about Lotic and Lentic ecosystems. So Lotic systems refer to streams and rivers. Streams have two habitat types. There's Lotic erosional, which is going to be fast-moving water that's eroding and carrying sediment with it. That tends to be on the outer banks and curves where the water is going to be moving faster. And the animals that we live there, we're going to see typically have claws for holding on. The Lotic depositional is going to be more slow-moving water. The water is slowing down, we get some deeper pools, and the sediment that was carried from the erosional zone is going to drop and fall out. So if we look here at our bank, we can see here we've got a pool that's forming and a point here where we're going to have erosion. This happens because our streams and rivers aren't straight lines, but they're curving. And streams and rivers are going to shift. They never stay in the same place unless humans interfere through channelization. On to our lentic systems, which include lakes, ponds, and wetlands. Today I want to focus on lakes. So in a lake habitat, it's going to be divided into three major zones: the littoral zone, the limnetic zone, and the profundal zone. The littoral zone is here on the edges where we have plants that are rooted in the soil. Some of them come out, some of them are totally submerged, but there's enough light reaching all the way down to the bottom for photosynthesis. The limnetic zone is out in the middle in the open water, where sometimes we could find floating plants, but it's too deep for those plants to have roots that are rooted in the soil. Here we still have plenty of light for photosynthesis, so we can find phytoplankton. The last zone, the profundal zone, is down at the very deep, very little light, too dark for photosynthesis. We're not going to find any plants down here. With lakes, we can measure their biological productivity. So that's how many plants and animals that are living in them and that that body of water can sustain. We have four categories that describe biological productivity. There's oligotrophic, which is low productivity. This tends to be very clear water, and humans will mistakenly consider it as being clean water. Often though, that low productivity is a sign of pollution, that there's been some sort of toxic chemical that's preventing life from growing. Then there's mesotrophic, which is going to have moderate levels, and eutrophic, which is going to have higher levels of biological productivity. And then there's hypereutrophic, very high. Usually that means there's lots of algae and plankton. The very high is also a sign, or can also be a sign of pollution. Typically that's going to be plant nutrients having too much nitrogen coming from agricultural runoff, either farms or ranching. In the case of lakes, the biological productivity we want somewhere in the middle, kind of like Goldilocks. We don't want it too high, we don't want it too low, just right in the middle. In our lakes, we're also going to see stratification in the water based on temperature. In the summertime, we're going to find warm water near the top. That's called the epilimnion, and this will always be very similar to air temperature. Then we're going to have a decline in the middle called the metalimnion, where we've got a change. That change in temperature is also called a thermocline. And the very bottom layer, the deepest layer, is going to be the coldest. That's the hypolimnion. That sort of overlaps with the profundal zone. And so here we can see our layers. So this epilimnion is going to be where there's the most productivity. And we're thinking of photosynthesis. It's near the surface, it's maximum light. Because of wind, we're getting mixing of the water. So the wind mixes in oxygen, the photosynthesis mixes in oxygen, and we need oxygen for life. Then as we go deeper, water temperature is going to decrease, and the amount of dissolved oxygen, that's what this DO stands for, also decreases. So we're going to find less life towards the bottom, less productivity, because there aren't going to be any plants down there because there's no light. So with our stratification, we get an event called turnover. So what turnover is it's the process of a lake's water turning over from top to bottom. This helps to cycle nutrients and oxygen throughout the lake. Typically, let's look back at our layers. Oxygen's at the top, and lots of nutrients are down here at the bottom from animals dying and their bodies sinking to the bottom to decompose. During the seasonal changes, so fall to winter, and then during the spring going towards summer, we get turnover. So during the summer, the epilimnion is the warmest, the hypolimnion is the coolest. But as we move through fall towards the winter, the epilimnion begins to cool. As it cools, it becomes more dense, causing it to sink. And as it sinks, it forces that bottom water up to the top, turning over our layers. Now let's look at our lakes versus ponds to finish up our notes. Generally speaking, so these are both lentic systems, meaning that they're standing or slow-moving bodies of water surrounded by land. Generally speaking, we use the term lake to describe a much bigger body of fresh water, and pond to describe a smaller one. Ponds can even be seasonal and not around all the time. One of the biggest difference between whether something should be considered a lake or a pond is going to be all that stratification. Do we have temperature variation? Then it's going to be a lake. Ponds tend to have much more uniform temperature. Lakes have that seasonal turnover. Ponds are shallow enough that all of their mixing is going to be due through the wind. Also with lakes, they're going to have that deep profundal zone where light doesn't reach the bottom. Ponds again are going to be smaller and shallower, and light will reach the bottom of a pond.